So looking at number 1 on the first practice test, it's asking us for domain, range, increasing, decreasing, constant, and any points of discontinuity. So for the domain, we're talking about all possible values of x. This graph starts off at negative infinity, goes to positive infinity, and we don't skip any values along the way. So our domain here should be negative infinity to infinity. Just remember on Blackboard, you're going to use the abbreviation INF instead of infinity because it doesn't have the capability of letting you use that notation, the infinity notation. Range, lowest and highest possible values of y and everything in between. All right, so in this case, our graph is starting off with a low y value of -4 and maxing out with a high y value of +4 and never skipping any values along the way. So our range here would go from -4 to 4. Increasing would be the part of the graph that's going uphill as you read the graph from left to right. So that would be this piece and this piece. So it's increasing from negative infinity to, it looks like a -1 here. All right, this point appears to be a solid point at -1. So I'm going to say comma -1 with a bracket. And then it starts increasing again at +1, solid point at +1. And then never stops increasing, keeps increasing out to infinity. Decreasing would be where the graph is going downhill from left to right. That's happening between -1 and 1, solid points on both ends. Constant would be where it has a 0 slope or flat lines. That never happens, so I'll say no solution for that. Points of discontinuities would be, kind of a break in the graph, a gap of some kind, a hole in the graph. So that's a no solution there also, because this graph extends from negative infinity to infinity without exclusion, or without excluding any values. Now, number 2, if g of x is equal to the absolute value of x minus 3, h of x is x squared plus 2x, find the value of g of h of 1 minus rad 2. There's a couple of ways to handle this. One way would be an algebraic approach, which is to say find g of h of x, which is telling us to take the g function and everywhere I have an x, replace it with the h function. All right, and so that would boil down to, because the h of x function is x squared plus 2x, that would be telling us, all right, rewrite this, but where I have h of x, make it x squared plus 2x, and then once I do that, we would find g of h of 1 minus the square root of 2. So everywhere I have an x in this function, replace it with a 1 minus the square root of 2. And then simplify. All right, but the simplifying part is going to happen on Desmos because, if you look at this, it's not too neighborly. So you would type in absolute 1 minus, 1 minus the square root of 2, close it up, square it, plus 2 parentheses 1 minus the square root of 2, close it up, minus 3, and then round this answer however the instructions on the test tell you to round it. 3 significant digits is usually the way to go, so 3.657. All right, I mentioned there was another way to do it. The other way to do it would be to type in your original g of x, so absolute x minus 3, type in your original h of x, x squared plus 2x. And then just type in the expression they give you, g of h of 1 minus the square root of 2. Oops, I don't need to do that. Just close this one, then there we go. And you'll get the same answer. Either way is fine. On the test, if you need to submit work for a question like this, just submit your Desmo share link. Number 3, we're looking for vertical asymptotes. For vertical asymptotes, you set your denominator equal to 0 and solve for the value of x. You could get more than one solution. This one's factorable, x minus 4x plus 3. Set each of those factors equal to 0 and solve. Alright, so these would be my vertical asymptotes. If you're a little iffy on your algebra skills, what you could do is graph your denominator, y equals x squared minus x minus 12, and see where the x-intercepts are, -3, +4, and that'll give you your vertical asymptotes. For the horizontal asymptotes, we're looking at the highest power on the top of the fraction, we call that m. The highest power on the bottom of the fraction, we call that n. So in this case, m is equal to 1, n is equal to 2. The relationship here is that m is less than n. In your notes, so take a look at your notes under horizontal asymptotes. If m is equal to n, then your horizontal asymptote is the line y equals 0. Alright, so that's probably the most straightforward way of taking care of that one. Alright. In terms of which of the functions has an inverse that's also a function, there's a couple of ways to handle this one. One would be to graph each of them. Let me just clear out some of this stuff. You know, I could just type in y equals x cubed plus x. That's my original function. Wonderful. It's not really the original that I'm interested in. It's I want to know is its inverse going to be a function. So I can graph the inverse without figuring out what it is analytically, just by swapping x with y. So x equals y cubed plus y. Take a look at my inverse function and see if it passes the vertical line test. So I'll just plot a vertical line here and see if, no matter where I draw that vertical line, it only intersects at most one time. And that's the case here. So luckily we're able to figure it out on the first shot. But let me show you one that doesn't work. So this is the correct answer. Let's say I was looking at the last one. All right. So the last one is x squared minus 2x plus 1. All right. So turn that on. That's what that parabola looks like. I'll graph that by switching the x and the y. So y squared minus 2y plus 1. Again, I only care about the inverse, but just so you see the relationship between the graph and its inverse. I'll turn off the original function. You'll see here that we're looking at multiple intersections. All right. There is one instance where there's only one intersection, but if there's ever an instance in which there's more than one intersection, then the inverse is not a function. All right. So that's an example of a case where it doesn't work out. But basically, if your function is an odd function, its inverse will also be a function. Alright, so that's a little tip. Nice easy one. Find the end behavior model. If you remember, that's the one where we take the term on the top and the bottom, or the terms on the top and bottom with the highest power, and divide them. So y would be equal to x cubed over x squared. This technique only works for rational functions, but that's the only kind of function we're dealing with right now, so that's the only kind of function I'll give you on the test. So it should be pretty easy to do. All right, so y equals x is the end behavior model, and that's all she wrote.